Hi guys, we're going to pick up with solving rational equations. So previously we did adding and subtracting rational expressions, and what we're going to do is something similar to that. What we need to do is actually find a least common denominator, and then instead of just simplifying those expressions, once we find the least common denominator, we're actually going to have an equation to solve. So let's go ahead and take a look at this one right here. So the first thing you would always look for is, can I factor any of my denominators? Because that's the first thing you want to do. We can't do that here, so we go right to finding the least common denominator. So in this problem, our least common denominator between these three is going to be 6x squared. So now what we need to do is correct our numerators to have this least common denominator of 6x squared. So I'm going to rewrite my equation with that least common denominator. Now, in order to make 6x a 6x squared, and let me go ahead and put everything else that I have up top here first. So in order to do that, make a 6x a 6x squared, you have to multiply the top and the bottom by x. So I'm going to put that here. In order to make a 3x squared a 6x squared, I have to multiply the top and the bottom by 2. And then in order to make a 2x squared a 6x squared, I have to multiply the top and bottom by 3. So this is what I do to correct for the numerators. And now I can just go ahead and simplify the numerators. So that's going to give me x over 6x squared plus 2 over 6x squared is equal to 9 over 6x squared. Now, once you have your equation written with the least common denominator, we can just ignore the denominator right now and solve the equation that you get with just the numerators. So in other words, I can just get rid of this here and say I'm going to solve this equation, which is x plus 2 is equal to 9. So we're going to go ahead and do that. Now this is just a one step, so we'll just subtract 2. And you get x is equal to 7. Now normally you have to go back in and check to make sure that the 7 is true, that you don't have an extraneous solutions. But for all the problems that we're doing in this video, they will be true. So let's take a look at number 2. So we have 4 over 2x minus 5 is equal to 1 over 2x plus 1 over 4x squared minus 10x. So now looking at the denominators, we can go ahead and factor this denominator right here. So I can just do that right underneath it. And when I do that, I could take out a 2x, and that's going to leave me with 2x minus 5. So now I have 2x minus 5 here, I have a 2x here, and then I have 2x times 2x minus 5. So our least common denominator is going to be 2x times 2x minus 5. So I can go ahead and write these fractions with our least common denominator. So I'm going to go ahead and do that. I already have a 4 up here. So 2x times 2x minus 5, I have a 1. And then here, I know I'm not going to need to correct for that, because that is going to be my least common, it is our least common denominator. I'm not going to have to do any correction for that. So now looking at this, I have a 2x minus 5, and I need to get the 2x times 2x minus 5. So that means I have to multiply by 2x. And then here, I have 2x, and I need to get 2x times 2x minus 5. I have to multiply this by 2x minus 5. And of course, like I said, this is our least common denominator, so I do not have to correct for that. So now, just like we did over here, I can just get rid of this right here, the denominator, because we're going to solve what's in the numerator here. So if I go ahead and start simplifying that, that's going to give me 8x is equal to 1 times 2x minus 5, which is going to be 2x minus 5, and then I have the plus 1. So I'm going to go ahead and finish solving that. So like terms, I get 8x is equal to 2x minus 4, negative 5 plus 1. And then I can go ahead and move the 2x over, so subtract 2x from both sides. So that's going to give me 6x is equal to negative 4. And then I can go ahead and divide both sides by 6. And then that is going to give me x is equal to negative 2/3. And again, this is true. We don't have to plug it in and check for an extraneous solutions, because with the problems I'm doing, this would definitely be true. All right, so let's go ahead and take a look at problem number 3. All right, so you can see I got problems 3 and 4 up here. So taking a look at number 3, there's nothing we can factor down in the denominator, so we can just go ahead and look for our least common denominator, which for this particular problem is going to be 4x times x minus 1 for our least common denominator. So now I can go ahead and correct for our numerators. I'm going to write our denominators as the least common denominator, and then we will correct for our numerators. I'm going to put down what I already have here, the 6, the 9, and the 1. So in order to make an x a 4x times x minus 1, I'm going to have to multiply by 4 times x minus 1, because I already have the x. Let me go ahead and highlight that. And then to make this a 4x times x minus 1, I have to multiply by 4x, because I already have the x minus 1 here. And then in order to make a 4x times x minus 1, I need to multiply by the x times x minus 1, because I already have the 4. All right, so now we can go ahead and get rid of this right here. Instead of rewriting it all, I'm going to just get rid of that and make this the equation. So I'm going to simplify the numerators and write it as the equation that we're going to use to solve. So this would become 24 times x minus 1 minus, that becomes 36x is equal to, and this just becomes x times x minus 1. So that is the equation that we are going to solve. So from here, I'm going to distribute, and then minus 36x is equal to x squared minus x. Look for any like terms. So then I got the 24x and the minus 36x. So negative 12x minus 24 is equal to x squared minus x. And now at this point, I see I got a quadratic. So I'm going to want to set this equal to 0, and hopefully it'll be factorable. So I'm going to add 12x, add 24. So that's going to give me x squared plus 11x plus 24. And now from here, I'm going to go ahead and factor that. And when you do factor it, it becomes x plus 8 times x plus 3. And now, of course, I'm going to go ahead and just solve those. So you set each factor equal to 0 and solve. And then by doing that, subtract 8 here. I get x is equal to negative 8. And then over here, I get x is equal to negative 3. So then our solutions for this, negative 8 and negative 3. And of course, those are going to work. It's the same thing. These problems that we're doing, all these solutions are going to be true. So let's look at number 4 here. So this denominator, we can go ahead and factor. I'll just factor it right underneath, which that's going to be x plus 6 times x plus 1. It's just going to save us a little time instead of rewriting all this. So then I have x plus 1, x plus 1, and x plus 6, and then x plus 6. So our least common denominator is actually going to be this right here. So it's going to be x plus 6 times x plus 1. So now I can go ahead and rewrite with our least common denominator and correct for our numerators. So I have x plus 6 times x plus 1 equals that x plus 6 times x plus 1 plus So we got that all written out. Put what I have up top already. And now let's see what we need to correct for in the numerator. So I already have the x plus 1, so I need the x plus 6. So we're going to use that one right there. And then here I already have the least common denominator, so there's nothing to correct for up top here. Here I have x plus 6, I need the x plus 1. So again, instead of rewriting it, save some time. This, we're going to get rid of that, and we're going to solve. Take these, all these numerators are going to be the equation. So when I do that, it gives me x plus 6 is equal to 6 plus 3 times x plus 1. And then I'm just going to go ahead and solve that. So I got x plus 6 is equal to 6, distribute first. And then look for to combine some like terms. So that'd be 3x plus 9. And then I'll just go ahead and subtract x here. So 6 is equal to 2x plus 9. And then I will subtract 9. And then that will give me negative 3 is equal to 2x. And I'll divide by 2 for the final step here. So x is equal to negative 3/2. And that is our solution for number 4. So we'll go ahead and take a look at number 5. All right, let's look at number 5. You see we got the 2x and x plus 1 in the denominator. And over here, we don't have anything written, but we know it's a 1, but that's not going to affect the least common denominator. So there's nothing I can factor here. So our least common denominator for this problem is actually going to be 2x times x plus 1. So I can go ahead and rewrite our equation with the least common denominator. Go ahead and put what I already have in my numerators. And now I need to go ahead and correct for those numerators. So in order to make 2x a 2x times x plus 1, I got to multiply by x plus 1. In order to make an x plus 1 the 2x times x plus 1, I got to multiply by 2x. And then here, again, there's a 1 here, so I got to multiply by everything. So times 2x times x plus 1. So this is everything that I'm doing to correct for my numerators. So now I can basically get rid of this, and all of my numerators are going to be the equation I'm going to solve. So I could do a little simplifying as I'm rewriting it. So distributive property here would be 3x plus 3 minus, that would be 4x squared. I can multiply these two, which is minus 4x times x plus 1. So now I can go ahead and do the distributive property here. So I got 3x plus 3 minus 4x squared is equal to negative 4x squared minus 4x. And now let me go ahead and solve. So I'm going to move over to get the x squareds to one side, but look what happens when I do that. They actually all cancel out. So then I'm just left with 3x plus 3 is equal to negative 4x. And then I can go ahead and subtract my 3x over. And that would give me 3 is equal to negative 7x. And then, of course, I'm going to divide by negative 7. And that will leave me with x is equal to negative 3/7. And that is the answer to number 5. All right, so hopefully this helped you with solving the rational equations, and we'll look at maybe some more difficult ones that include extraneous solutions in the next video.